Hi, this is me Padma Devi. Today we are going to see video 2 of matrices. So if anybody want to see video 1, I have given the link in the description. Just go through it. Yes, now in this video we are going to see two things. One is types of matrices and the other one is equality of matrices. Let's start with the types of matrices. Before proceeding with these types of matrices, we need to just recall what is matrices, right? Matrix can be usually represented with a capital letter and which is enclosed with a square bracket. Inside a square bracket we will be having the elements, right? So now I will be giving you an example of one matrices. Yeah, so a matrix A is equal to, so this is going to have the elements like this: 1, 2, 3. So what this matrix is having, see, it is having 3 rows and only 1 column. So if any matrix is having the elements only in the column, then I can say it's a column matrix. The next one is the row matrix. So any matrix which is having only one row irrespective of its column, I can say it's a row matrix. See, this matrix is having only one row but 3 columns are there. So this is the row matrix. The next one is a square matrix. So before seeing this, I just want to give a small recap on order of a matrices, right? So what is an order of a matrices? Any matrices can be represented with number of rows and columns. It's nothing but the order. So how we will represent? M cross N, right? So if your M and N both are equal, then I can say it's a square matrix. So what is M? The number of rows. N is number of column. Here what it is saying, if both the number of rows and number of columns are equal, then I can say it's a square matrices. So now I am taking 2 cross 2 matrix. See here, 1, 2, 3, 4. So it is having 2 rows and 2 columns. And see, I am going to take 3 cross 3 matrices: 4, 5, 6, 7, 8, 9, 1, 2, 3. See here, it is having 3 rows and 3 columns. So I can say these both are square matrices. This matrix is of 2 cross 2 and this matrix is of 3 cross 3. Both number of rows and number of columns are equal and it is looking like a square too. So this is how it's a square matrix. Yes, the next one is the diagonal matrix. So any matrix which is going to have the element only at the diagonal, then I can say it's a diagonal matrix. Just to see the example of a matrix, see here, only in the diagonal part we are having the element. See this one and this one, usually we will say this as upper triangle, this as lower triangular part. So apart from upper triangular and lower triangular, only the diagonal is having the element. Both upper triangle and lower triangle is having element of only zeros. So I can say this as a diagonal matrix. It's nothing, the diagonal alone is going to have the values, all the other elements are going to have 0 as the value, then I can say it's a diagonal matrix. Now the next one is scalar matrix. Scalar matrix is also a diagonal matrix, but when your diagonal is having a same number of value, so I'm putting here 2, 0, 0, 0, 2, 0, 0, 0, 2. See here, only the diagonal is having the values. It's a diagonal matrix, but these diagonal values are identical, same, right? Then I can say it's a scalar matrix. Now the next one is identity matrix. What is an identity matrix? This is also again a diagonal matrix, but your diagonal should have only the element 1. Then I can say it's an identical matrix. And the last one, zero matrix. The other name for zero matrix is null matrix. What is the zero matrix? This matrix is going to have the element of only 0. No other element will be there in this matrix. Then I can say it's a zero matrix or null. Now we will see what is equality of matrices. It's nothing but we are going to check whether the given two matrices are equal to each other or not by comparing the corresponding elements of the two matrices. But here one thing we need to remember, that we are comparing two matrices, right? They both should be in the same order. For example, if the one matrix is 2 cross 2, then the other matrix which we are comparing with this matrix should be 2 cross 2. So just to see, I'm taking one matrix which is A, 1, 2, 3, 4, and I'm taking another matrix B. It is also having the same element on the corresponding position. See here, in the first row first column I'm having the element as 1. Here also first row first column the same value. So the corresponding element should be same for both the matrices. Then I can say it's an equality of the matrices. And see here, first row second column, and here also first row second column both are equal. And see here, second row first column, second row first column both are equal. And here second row second column, second row second column both are equal. See, so all the elements of one matrix is equivalent to the all the elements correspondingly of the second matrices. Then I can say it's the two given matrices are equal to each other. So we can use this concept for solving some unknown variable. Maybe for example, see, I can say A is having 1x 2z. Okay, now B is having an element y 10 2 5. Okay, now in this first given matrix we are having two unknown variable which is x, another one is z. In the second matrices we are having an unknown variable as y. So we are going to find the value of these unknown variable by the equality of matrices. It is given that A is equivalent to B. Then only we can find the value by comparing these two. Yes. Now X is in first row second column. Just to check the another matrix, what is the value of first row second column? It is 10. So your X value is 10. Yes. Now Y, where it is residing, it is, yeah, it's in first row first column. Now check the equivalent matrices, first row first column, it is 1. So Y value is 1. And now Z is the last variable which is in the position of second row second column. So we need to check the same position with the equivalent matrices. So what is the same position? Second row second column, it is 5. So Z is going to be 5. This is how we are using this equality of matrices concept to find the unknown variables. Yes, hope you all understood. Let's see in the next video. Thank you. Bye bye.